The Advanced Research Projects Agency network was one of the world's first operational packet switching networks, the first network to implement TCP/IP, and the progenitor of what was to become the global Internet. The network was initially funded by the Advanced Research Projects Agency within the U.S. Department of Defense for use by its projects at universities and research laboratories in the U.S. The packet switching of the Arpanet, together with TCP/IP, would form the backbone of how the Internet works. The packet switching was based on concepts and designs by American engineer Paul Baran, Welsh scientist Donald Davies and Lawrence Roberts of the Lincoln Laboratory. The TCP/IP communication protocols were developed for Arpanet by computer scientists Robert Kahn and Vinton Cerf, and also incorporated some designs from Louis Pouzin. History. Packet switching. Today the dominant basis for data communications worldwide. Was a new concept at the time of the conception of the Arpanet. Prior to the advent of packet switching, both voice and data communications had been based on the idea of circuit switching, as in the traditional telephone circuit, wherein each telephone call is allocated a dedicated, end-to-end, electronic connection between the two communicating stations. Such stations might be telephones or computers. The dedicated line is typically composed of many intermediary lines which are assembled into a chain that stretches all the way from the originating station to the destination station. With packet switching, a data system could use a single communication link to communicate with more than one machine by collecting data into datagrams and transmitting these as packets onto the attached network link, as soon as the link becomes idle. Thus, not only can the link be shared, much as a single post box can be used to post letters to different destinations, but each packet can be routed independently of other packets. The earliest ideas for a computer network intended to allow general communications among computer users were formulated by computer scientist J.C.R. Licklider of Bolt, Beranek and Newman, in April 1963, in memoranda discussing his concept for an intergalactic computer network. Those ideas contained almost everything that composes the contemporary Internet. In October 1963, Licklider was appointed head of the Behavioral Sciences and Command and Control Programs at the Defense Department's Advanced Research Projects Agency ARPA. He then convinced Ivan Sutherland and Bob Taylor that this computer network concept was very important and merited development, although Licklider left ARPA before any contracts were let that worked on this concept. Ivan Sutherland and Bob Taylor continued their interest in creating such a computer communications network, in part, to allow ARPA-sponsored researchers at various corporate and academic locales to put to use the computers ARPA was providing them, and, in part, to make new software and other computer science results quickly and widely available. In his office, Taylor had 3 computer terminals, each connected to separate computers, which ARPA was funding, the first, for the System Development Corporation Q32, in Santa Monica. The second, for Project Genie, at the University of California, Berkeley. And the third, for Multics, at MIT. Taylor recalls the circumstance: for each of these 3 terminals, I had 3 different sets of user commands. So, if I was talking online with someone at SDC, and I wanted to talk to someone I knew at Berkeley, or MIT, about this, I had to get up from the SDC terminal, go over and log into the other terminal and get in touch with them. I said, "Oh man. It's obvious what to do. If you have these 3 terminals, there ought to be one terminal that goes anywhere you want to go. That idea is the Arpanet." Meanwhile, other people had been working in the same field. Paul Baran at the RAND Corporation had been researching systems that could survive nuclear war from the early 1960s, and in the United Kingdom National Physical Laboratory presented the first public demonstration of packet switching on August 5, 1968. Creation. By mid-1968, Taylor had prepared a complete plan for a computer network, and, after ARPA's approval, a request for quotation was sent to 140 potential bidders. Most computer science companies regarded the ARPA-Taylor proposal as outlandish, and only 12 submitted bids to build the network. Of the 12, ARPA regarded only 4 as top-rank contractors. At year's end, ARPA considered only 2 contractors, and awarded the contract to build the network to BBN Technologies on April 7, 1969. The initial, 7-person BBN team were much aided by the technical specificity of their response to the ARPA RFQ Euro, and thus quickly produced the first working computers. This team was led by Frank Hart. The BBN proposed network closely followed Taylor's ARPA plan, a network composed of small computers called interface message processors, that functioned as gateways interconnecting local resources. At each site, the IMPs performed store and forward packet switching functions, and were interconnected with modems that were connected to leased lines, initially running at 50 kbit/second. The host computers were connected to the IMPs via custom serial communication interfaces. The system, including the hardware and the packet switching software, was designed and installed in 9 months. The first-generation IMPs were initially built by BBN Technologies using a rugged computer version of the Honeywell DDP-516 computer configured with 24 kilobytes of expandable core memory, and a 16-channel direct multiplex control direct memory access unit. The DMC established custom interfaces with each of the host computers and modems. In addition to the front panel lamps, the DDP-516 computer also features a special set of 24 indicator lamps showing the status of the IMP communication channels. Each IMP could support up to 4 local hosts, and could communicate with up to 6 remote IMPs via leased lines. The network connected 1 computer in Utah with 3 in California. Later, the Department of Defense allowed the universities to join the network for sharing hardware and software resources. Misconceptions of design goals. It is commonly said that ARPANET was designed to survive a nuclear attack. In A Brief History of the Internet, the Internet Society denies this. It was from the RAND study that the false rumor started, claiming that the ARPANET was somehow related to building a network resistant to nuclear war. This was never true of the ARPANET, only the unrelated RAND study on secure voice considered nuclear war. However, the later work on interneting did emphasize robustness and survivability, including the capability to withstand losses of large portions of the underlying networks. The RAND study was conducted by Paul Baran and pioneered packet switching. In an interview he confirmed that ARPANET did not share his project's goal, but also argued that his work had greatly contributed to the development of ARPANET. The ARPANET incorporated distributed computation of routing tables. This was a major contribution to the good survivability that the ARPANET had, in the face of significant destruction, even by a nuclear attack. Such auto-routing was technically quite challenging to construct at the time. The fact that it was incorporated into the early ARPANET made many believe that this had been a design goal. The ARPANET was in fact designed to survive subordinate network losses, but the principal reason was that the switching nodes and network links were unreliable, even without any nuclear attacks. About the resource scarcity that spurred the creation of the ARPANET, Charles Hezeld, ARPA director, said, "The ARPANET was not started to create a command and control system that would survive a nuclear attack, as many now claim. To build such a system was, clearly, a major military need, but it was not ARPA's mission to do this. In fact, we would have been severely criticized had we tried. Rather, the ARPANET came out of our frustration that there were only a limited number of large, powerful research computers in the country, and that many research investigators, who should have access to them, were geographically separated from them." Arpanet Deployed. The initial ARPANET consisted of 4 IMPs, University of California, Los Angeles, where Leonard Kleinrock had established a network measurement center, with an SDS Sigma 7 being the first computer attached to it. The Stanford Research Institute's Augmentation Research Center, where Douglas Engelbart had created the groundbreaking NLS system, a very important early hypertext system, and would run the Network Information Center, with the SDS 940 that ran NLS, named Genie, being the first host attached. University of California, Santa Barbara, with the Color-Fried Interactive Mathematics Center's IBM 360/75, running OS/MVT being the machine attached. The University of Utah's Computer Science Department, where Ivan Sutherland had moved, running a DECP-DP-10 operating on TENEX. The first message on the ARPANET was sent by UCLA student programmer Charlie Klein, at 10:30 p.m. on October 29, 1969, from Boelter Hall 3420. Klein transmitted from the university's SDS-Sigma-7 host computer to the Stanford Research Institute's SDS-940 host computer. The message text was the word login. The L and the O letters were transmitted, but the system then crashed. Hence, the literal first message over the ARPANET was low. About an hour later, having recovered from the crash, the SDS-Sigma-7 computer effected a full login. The first permanent ARPANET link was established on November 21, 1969, between the IMP at UCLA and the IMP at the Stanford Research Institute. By December 5, 1969, the entire 4-node network was established. Growth and evolution. In March 1970, the ARPANET reached the east coast of the United States, when an IMP at BBN in Cambridge, Massachusetts was connected to the network. Thereafter, the ARPANET grew, 9 IMPs by June 1970 and 13 IMPs by December 1970, then 18 by September 1971. 29 IMPs by August 1972, and 40 by September 1973. By June 1974, there were 46 IMPs, and in July 1975, the network numbered 57 IMPs. By 1981, the number was 213 host computers, with another host connecting approximately every 20 days. In 1973, a transatlantic satellite link connected the Norwegian seismic array to the ARPANET, making Norway the first country outside the U.S. to be connected to the network. At about the same time, a terrestrial circuit added a London IMP. In 1975, the ARPANET was declared operational. The Defense Communications Agency took control since ARPA was intended to fund advanced research. In 1983, the ARPANET was split with U.S. military sites on their own military network for unclassified Defense Department communications. The combination was called the Defense Data Network. Separating the civil and military networks reduced the 113-node ARPANET by 68 nodes. Gateways relayed electronic mail between the two networks. Milnet later became the NIPNet. Rules and etiquette. Because of its government ties, certain forms of traffic were discouraged or prohibited. A 1982 handbook on computing at MIT's AI lab stated regarding network etiquette: it is considered illegal to use the ARPANET for anything which is not in direct support of government business. Personal messages to other ARPANET subscribers are generally not considered harmful. Sending electronic mail over the ARPANET for commercial profit or political purposes is both antisocial and illegal. By sending such messages, you can offend many people, and it is possible to get MIT in serious trouble with the government agencies which manage the ARPANET. Technology. Support for inter-IMP circuits of up to 230.4 kbits was added in 1970, although considerations of costs and IMP processing power meant this capability was not actively used. 1971 saw the start of the use of the non-ruggedized Honeywell 316 as an IMP. It could also be configured as a terminal interface processor, which provided terminal server support for up to 63 ASCII serial terminals through a multi-line controller in place of one of the hosts. The 316 featured a greater degree of integration than the 516, which made it less expensive and easier to maintain. The 316 was configured with 40 kilobytes of core memory for a TIP. The size of core memory was later increased, to 32 kilobytes for the IMPs, and 56 kilobytes for TIPs, in 1973. In 1975, BBN introduced IMP software running on the Pluribus multiprocessor. These appeared in a few sites. In 1981, BBN introduced IMP software running on its own C/30 processor product. In 1983, TCP/IP protocols replaced NCP as the ARPANET's principal protocol, and the ARPANET then became one subnet of the early Internet. Shutdown and legacy. The original IMPs and TIPs were phased out as the ARPANET was shut down after the introduction of the NSFNET, but some IMPs remained in service as late as 1989. The ARPANET Completion Report, jointly published by BBN and ARPA, concludes that, a. It is somewhat fitting to end on the note that the ARPANET program has had a strong and direct feedback into the support and strength of computer science, from which the network, itself, sprang. In the wake of ARPANET being formally decommissioned on February 28, 1990, Vinton Cerf wrote the following lamentation, entitled Requiem of the ARPANET. It was the first, and being first, was best, but now we lay it down to ever rest. Now pause with me a moment, shed some tears. For auld lang syne, for love, for years and years, of faithful service, duty done, I weep. Lay down thy packet, now, O friend, and sleep. Vinton Cerf. Senator Albert Gore, Jr. began to craft the High-Performance Computing and Communication Act of 1991 after hearing the 1988 report toward a national research network submitted to Congress by a group chaired by Leonard Kleinrock, professor of computer science at UCLA. The bill was passed on December 9, 1991 and led to the National Information Infrastructure which Al Gore called the Information Superhighway. ARPANET was the subject of two IEEE milestones, both dedicated in 2009. Software and Protocols, the starting point for host-to-host communication on the ARPANET in 1969 was the 1822 protocol, which defined the transmission of messages to an IMP. The message format was designed to work unambiguously with a broad range of computer architectures. An 1822 message essentially consisted of a message type, a numeric host address, and a data field. To send a data message to another host, the transmitting host formatted a data message containing the destination host's address and the data message being sent, and then transmitted the message through the 1822 hardware interface. The IMP then delivered the message to its destination address either by delivering it to a locally connected host, or by delivering it to another IMP. When the message was ultimately delivered to the destination host, the receiving IMP would transmit a ready-for-next message acknowledgement to the sending, host IMP. Unlike modern Internet datagrams, the ARPANET was designed to reliably transmit 1822 messages, and to inform the host computer when it loses a message. The contemporary IP is unreliable, whereas the TCP is reliable. Nonetheless, the 1822 protocol proved inadequate for handling multiple connections among different applications residing in a host computer. This problem was addressed with the Network Control Program, which provided a standard method to establish reliable, flow-controlled, bidirectional communications links among different processes in different host computers. The NCP interface allowed application software to connect across the ARPANET by implementing higher-level communication protocols, an early example of the protocol layering concept incorporated to the OSI model. In 1983, TCP/IP protocols replaced NCP as the ARPANET's principal protocol, and the ARPANET then became one component of the early Internet. Network applications. NCP provided a standard set of network services that could be shared by several applications running on a single host computer. This led to the evolution of application protocols that operated, more or less, independently of the underlying network service. When the ARPANET migrated to the Internet protocols in 1983, the major application protocols migrated with it. Email. In 1971, Ray Tomlinson, of BBN sent the first network email. By 1973, email constituted 75% of ARPANET traffic. File transfer. By 1973, the file transfer protocol specification had been defined and implemented, enabling file transfers over the ARPANET. Voice traffic. The network voice protocol specifications were defined in 1977, then implemented, but, because of technical shortcomings, conference calls over the ARPANET never worked well. The contemporary Voice over Internet protocol was decades away. ARPANET in popular culture, computer networks, The Heralds of Resource Sharing, a 30-minute documentary film featuring Fernando J. Corbato, J.C.R. Lickleder, Lawrence G. Roberts, Robert Kahn, Frank Hart, William A. Sutherland, Richard W. Watson, John A. Pastor, Donald W. Davies, and economist, George W. Mitchell. Scenario: a February 1985 episode of the U.S. television sitcom Benson, was the first incidence of a popular TV show directly referencing the Internet or its progenitors. The show includes a scene where the ARPANET is accessed. There is an electronic music artist known as Arpanet, Gerald Donald, one of the members of Drexciya. The artist's 2002 album Wireless Internet features commentary on the expansion of the Internet via wireless communication, with songs such as NTT Docomo, dedicated to the mobile communications giant based in Japan. The television series The Americans featured the ARPANET in an arc involving espionage activities. Thomas Pynchon mentions ARPANET in his 2009 novel Inherent Vice, which is set in Los Angeles in 1970, and in his 2013 novel Bleeding Edge. In Colin McCann's 2009 novel Let the Great World Spin, 4 men in California work for ARPANET during the chapter Etherist in Book 2. During this section, the men are hacking the public payphone wires to New York while a high-wire artist is walking between the two towers of the World Trade Center. The high-wire artist is based on Philippe Petit and is the premise of the 2008 documentary, Man on Wire. The 1993 television series The X-Files featured the ARPANET in a Season 5 episode, titled, Unusual Suspects. John Fitzgerald Byers offers to help Susan Modsky by hacking into the ARPANET to obtain sensitive information. In The Person of Interest Season 2 Episode 11, Harold Finch mentions at the end scene that a hacker hacked into ARPANET in a hack that revolutionized the Internet and gives a hint that it was him by saying that the computer was homemade, a fact that was never known before. This is later confirmed in Season 3 Episodes 11 and 12, Lethe, and Alethea. See also, ARPA, a top-level domain used exclusively for technical infrastructure purposes, AmpNet, Amateur Packet Radio Network, Computer Networks, The Heralds of Resource Sharing, a Euro 1972 documentary film, Project Cybersea and a Euro 1970 Chilean National Net Project, Usenet, A Poor Man's ARPANET, References. Further reading, Norberg, Arthur L. O'Neill, Judy. Transforming Computer Technology, Information Processing for the Pentagon, 1962, a Euro 1982. Johns Hopkins University PPA 153, a Euro 196. ISBN A978-0-8018-6369-1A, IA History of the ARPANET, The First Decade I. Arlington, Virginia, Bolt, Beranek and Newman Incorporated, April 1, 1981. http, www.dticmil.get.trdoc. Location equals U2 and doc equals get.trdoc PDF and AD equals ADA 115440. Hoffner, Katie. Lyon, Matthew. Where Wizards Stay Up Late, The Origins of the Internet. Simon & Schuster. ISBN A0-7434-6837-6. Abate, Janet. Inventing the Internet. Cambridge, Massachusetts, MIT Press PPA 36, a Euro 111. Asina B003VPWY6E. ISBN A0-262-01172-7. Banks, Michael A. On the Way to the Web, The Secret History of the Internet and Its Founders. A Press Springer Verlag. ISBN A1-4302-0869-4. Salas, Peter H. Casting the Net, From ARPANET to Internet and Beyond. Addison Wesley. ISBN A978-0-201-87674-1. Waldrop, M. Mitchell. The Dream Machine, J.C.R. Lickleder and the Revolution That Made Computing Personal. New York, Viking. Asina B00008MNVW. ISBN A0-670-89976-3. The Computer History Museum, SRI International, and BBN celebrate the 40th anniversary of first ARPANET transmission. Computer History Museum. October 27, 2009. Oral Histories, Oral History Interview with Robert E. Kahn. University of Minnesota, Minneapolis, Charles Babbage Institute. April 24, 1990. Retrieved May 15, 2008. It focuses on Kahn's role in the development of computer networking from 1967 through the early 1980s. Beginning with his work at Paul Baran and Newman, Kahn discusses his involvement as the ARPANET proposal was being written and then implemented, and his role in the public demonstration of the ARPANET. The interview continues into Kahn's involvement with networking when he moves to IPTO in 1972, where he was responsible for the administrative and technical evolution of the ARPANET, including programs in packet radio, the development of a new network protocol, and the switch to TCP/IP to connect multiple networks. Oral History Interview with Vinton Cerf. University of Minnesota, Minneapolis, Charles Babbage Institute. April 24, 1990. Retrieved July 1, 2008. As Cerf describes his involvement with the ARPA network, and his relationships with Paul Baran and Newman, Robert Kahn, Lawrence Roberts, and the Network Working Group. Oral History Interview with Paul Baran. University of Minnesota, Minneapolis, Charles Babbage Institute. March 5, 1990. Retrieved July 1, 2008. Baran describes his work at RAND, and discusses his interaction with the group at ARPA who were responsible for the later development of the ARPANET. Oral History Interview with Leonard Kleinrock. University of Minnesota, Minneapolis, Charles Babbage Institute. April 3, 1990. Retrieved July 1, 2008. Kleinrock discusses his work on the ARPANET. Oral History Interview with Larry Roberts. University of Minnesota, Minneapolis, Charles Babbage Institute. April 4, 1989. Retrieved July 1, 2008. Oral History Interview with Stephen Lukasik. University of Minnesota, Minneapolis, Charles Babbage Institute. October 17, 1991. Retrieved July 1, 2008. Lukasik discusses his tenure at the Advanced Research Projects Agency, the development of computer networks in the ARPANET, detailed technical reference works, Roberts, Larry. Mariel, Tom. Toward a Cooperative Network of Time-Shared Computers. Fall AFIPS Conference Roberts, Larry. Multiple Computer Networks and Intercomputer Communication. ACM Symposium on Operating System Principles Davies, D.W. Bartlett, K.A. Scantlebury, R.A. Wilkinson, PTA Digital Communications Network for Computers Giving Rapid Response at Remote Terminals. ACM Symposium on Operating Systems Principles Roberts, Larry. Wessler, Barry. Computer Network Development to Achieve Resource Sharing. Proceedings of the Spring Joint Computer Conference, Atlantic City, New Jersey. Hart, Frank. Kahn, Robert. Ornstein, Severo. Crowther, William. Walden, David. The Interface Message Processor for the ARPA Computer Network. 1970 Spring Joint Computer Conference AFIPS Proc 36, 551 Euro 567 doi, 10.1145/1,476,936.1477021 Carr, Stephen. Crocker, Stephen. Cerf, Vinton. Host-Host Communication Protocol in the ARPA Network. 1970 Spring Joint Computer Conference AFIPS Proc 36, 589 Euro 598 doi, 10.1145/1,476,936.1477024. RFC 33 Ornstein, Severo. Hart, Frank. Crowther, William. Russell, S.B. Rising, H.K. Michelle, at the Terminal IMP for the ARPA Computer Network. 1972 Spring Joint Computer Conference AFIPS Proc 40, 243 euro 254, McCullen, John. Crowther, William. Cosell, Bernard. Walden, David. Hart, Frank. Improvements in the design and performance of the ARPA network. 1972 Fall Joint Computer Conference Party IFIPS Proc 41, 741 euro 754, Feinler, Elizabeth J. Postal, Jonathan B. Arpanet Protocol Handbook, NIC 7104. Menlo Park, Network Information Center, SRI International. Asina B000 EN 742 Kea, Roberts, Larry. The Evolution of Packet Switching. Proceedings of the IEEE 66, 1307. doi, 10.1109/PROC. 1978.1114. Roberts, Larry. The ARPANET and Computer Networks. ACMA, External Links, ARPANET Maps 1969-1977. California State University, Dominguez Hills. January 4, 1978. Retrieved May 17, 2012. Walden, David C. Looking back at the ARPANET effort, 34 years later. Living Internet. East Sandwich, Massachusetts, livinginternet.com. Retrieved August 17, 2005. Images of ARPANET from 1964 onwards. The Computer History Museum. Retrieved August 29, 2004. A timeline. Paul Baran and the Origins of the Internet. Rand Corporation. Retrieved September 3, 2005. Clean Rock, Leonard. The Day the Infant Internet Uttered Its First Words. UCLA. Retrieved November 11, 2004. A personal anecdote of the first message ever sent over the ARPANET, Doug Engelbart's role in ARPANET history. 2008. Retrieved September 3, 2009. Internet Milestones, Timeline of Notable Internet Pioneers and Contributions. Retrieved January 6, 2012. A timeline. Waldrop, Mitch. DARPA and the Internet Revolution. 50 Years of Bridging the Gap. DARPA PPA 78 to euro 85. Retrieved August 26, 2012. A.